In this activity, we'll learn about how cells can run on protein and fat as well as glucose. By the end of this video, you should be able to describe how organisms survive using these alternate sources of energy. So, most automobiles can run on only one type of fuel, gasoline. If you run out of fuel and can't get to a gas station, you're out of luck. In this chapter, we've examined the steps by which plants and animals and other organisms use glucose as fuel. But living organisms are more flexible than cars when it comes to fuel sources. They also have more complex needs because their fuel must provide not only energy, but also the raw materials for growth. Humans and other organisms have the metabolic machinery that allows them to extract energy and other valuable chemicals from proteins, fats, and a variety of carbohydrates. You can see some of those listed here in the image shown. For that reason, we are able to consume and efficiently utilize meals comprising various combinations of molecules. In the case of dietary carbohydrates, many are polysaccharides, multiple simple sugars linked together, rather than solely the simple sugar glucose. Before they can be broken down by cellular respiration, the polysaccharides must first be separated by enzymes into glucose or related simple sugars. Dietary lipids are broken down into their two constituent parts, which is a glycerol molecule and fatty acids. The glycerol is chemically modified into one of the molecules produced during glycolysis. It enters the glycolysis pathway at that step and is broken down to yield energy. The fatty acids, meanwhile, are chemically modified into acetyl-CoA, at which point they enter the Krebs cycle. Now, proteins are chains of amino acids. And after consumption, the chains are broken down chemically. And then each amino acid is broken down into first an amino group that may be used in the production of tissue or excreted in the urine. And secondly, a carbon compound that is converted to one of the intermediate compounds in glycolysis or the Krebs cycle, allowing the energy stored in its chemical bonds to be harnessed. In the end, humans, indeed all animals, are able to harvest energy from a variety of food sources beyond simple glucose. Whether a meal contains carbohydrates, lipids, proteins, or some combination thereof, the nutrients are chemically modified in some preliminary steps and then fed into the intermediate steps in glycolysis or into the Krebs cycle to furnish usable energy for the organism.